But otherwise, let's go ahead and get started. I'm Carrie Bourne. I'm from the Office of Continuing Education at UW-Whitewater, and we have hosted the Fairhaven Lecture Series here at Fairhaven Senior Services since 1983. This semester, we're talking about the first 20 years of the 21st century, and today we'll talk about some of those storms that seem to be in the news a lot more often with Dr. John Frye. He is in his 9th year at UW-Whitewater and is an associate professor of geography in the Department of Geography, Geology, and Environmental Science. He earned his bachelor's and master's degrees from Ball State University, and his PhD is from the University of Georgia. Dr. Frye is a broadly trained physical geographer with emphasis in meteorology and climatology, and his research interests focus around extreme weather events. His studies have included examining extreme weather at climate scale, long-term patterns, meteorological scales, why a particular event happened, when, and where it did, and societal impacts. How does it impact people and property? Dr. Frye is a storm chaser and has traveled all around the country chasing storms. Please welcome Dr. John Frye.
Thank you, and thank you for having me today. Like you said, we're going to talk a little bit about the storms of the first 20 years here of the 21st century, kind of look back and investigate some events, talk about some events that have occurred around here and elsewhere in the United States, and kind of talk about those and in terms of the weather patterns and the kind of societal impacts as well. And I would like to comment, there's always weather outside, right? Just because it's snowing, there's always weather. So, like I said, we're going to take a look at the first 20 years here of the 21st century, and we're going to kind of, again, look at this from two different perspectives. And the first one is under the perspective of climate change. Climate has been changing on our planet since day one. Some of the changes that have occurred are naturally occurring because of natural things that happen on our planet. But over the last 160 years, since the mid-1800s when the Industrial Revolution started, we have been having an impact as humans. We have been burning fossil fuels, whether that's coal, gas, natural gas, which is changing our atmosphere. We have also increased our population as well, and that's having an impact on our climate. So you can see the animation here. This is a time scale of the temperatures around the planet from 1884 to 2019. The baseline here, the 0 point, is the 20th century mean, so the 1900s. Anything that's blue was less than the mean, so a negative anomaly. And anything in the yellows and oranges and reds are a positive anomaly or above normal, above that average. And you can see the map starts out at the beginning, back in the 1800s, early part of the 1900s, it's mostly blue. We're below that 20th century mean. But as we get to more modern times, our planet's been warming. Not everywhere on our planet is getting warmer. There are some small pockets that are getting colder, but overall, the entire planet is warming. In fact, of the top 20 years, warmest years on our planet on record, 19 of them have been since the year 2000. 19 out of the 20. So that's the world we're living in now, this world of climate change. And we tend to focus on temperature, but that's not what I'm going to focus on today. I'm going to focus on some other aspects of weather. And again, the other thing I'm going to talk about here is the societal impacts. Again, weather impacts us every day. Most of us want to know what the weather is. We want to know, can we go outside in shorts? Do we need our winter jackets? Do we need our hats like on a day like today? Or can we go out and enjoy the nice sunny weather? So weather impacts our lives from day to day. It impacts the way we build our houses. It impacts transportation. There's a lot of things that weather impacts. So we'll talk about some of these societal impacts that we have faced as well. So again, I'm not going to focus on temperature. If you pay attention to the news, you've heard about temperature. I'm going to focus on these three subjects. We're going to talk about precipitation changes. We're going to talk about changes in hurricane patterns and thunderstorm patterns. And again, focus on the last 20 years since the year 2000. So let's start with precipitation, and we're going to focus here right in the Midwest because we have plenty of things to talk about. I just pulled out two events that I thought were noteworthy since the year 2000. The first one we'll talk about is the 2008 Midwest floods. You can see an aerial picture here from an aircraft of some of that flooding that occurred during that year. Even right here in this area was very impacted by that. And then we're going to switch gears and we're going to talk about some wintertime precipitation, and we'll look at the 2011 Groundhog Day blizzard that occurred again right here in this area. So first, let's talk about how precipitation is changing from a climate perspective. It's not as straightforward as temperature changes. Depending on where you go around the planet, some areas are getting wetter, some areas are getting drier. And so it's not as uniform as our temperature patterns are in that map that we saw, that animation we saw at the beginning. So what you're looking at here is some precipitation data from Baraboo, Wisconsin. This is actually some research that one of my students has been working on over the last 2 years, looking at how precipitation is changing over the upper Great Lakes region. We've looked at over 250 stations in Minnesota, Wisconsin, and Michigan, and we've analyzed the precipitation records for that time period. The purple line here, the thin purple line that you see, is the total annual precipitation. So any precipitation that falls throughout the year, we measure that, we sum those totals up, and we get an annual total precipitation. So you can see a lot of variability there. But if we apply a simple statistical trend line to that, you can see that the rate of total precipitation is on the rise. And we're seeing this all over that three-state area that we have been analyzing in the data. The orange represents the number of days in which we receive precipitation. Doesn't matter if it was a trace, doesn't matter if it was 14 inches. If it occurred sometime in that 24-hour period, we count it as a precipitation day. And since the 1950s, that same timeline, those number of days that we receive precipitation have been on the decline. So, precipitation totals are going up, while precipitation days are decreasing. So this is telling us that we're getting more precipitation, but it's occurring in fewer days. So that could be impactful when we get what we're calling extreme precipitation events. Maybe our storm systems in our urban areas can't handle that amount of precipitation. They're only rated to handle so much water at a given time. That's increasing erosion in our farm fields. That's increasing stream flows in our streams. But then we also have a larger gap between precipitation events, so that could lead to some drought, small drought-like conditions. That could be impactful for farmers if it happens at the wrong time of the year, if they need that precipitation to allow their crops to grow, or if we get one of those extreme rainfall events when it's time to harvest or plant. It's going to be hard for them to do their job. So this is part of what precipitation is doing here in the upper Great Lakes region. So those particular events kind of show some of the impacts of these events. So this is a rainfall map from 2008, June 5th through June 13th. So it's an 8-day rainfall total. And you can see Wisconsin here, the blue area right there, kind of up in the central part of the state, 14 inches of rain over that 8-day period. So a very large precipitation event. Now, Wisconsin wasn't the only state that was impacted by this. Iowa, Illinois, Minnesota, Michigan, Indiana, all those states were impacted from this. This event caused over $6 billion in damage when it occurred. A lot of the research that you read about this event and when this event happened, there were a lot of comparisons between this event and the 1993 Midwest floods that mainly happened along the Mississippi and Missouri rivers a little bit to our west. And some of the analysis that they looked at is there were some areas that got hit by both events. And what they found out is that this event, the 2008 event, was a little more localized. So you had these small pockets of extremely heavy rainfall. Whereas the 1993 flood event, there was not as much rainfall, but it was spread out over a larger area. And so the flooding was a little bit different with that. But we did see improvements that were made after the 1993 event did help in the areas that were impacted by this. They didn't get impacted by the flooding like they did back in 1993 because of some of the improvements they made. The other thing from a societal standpoint that we saw when comparing 1993 to 2008 is we may be the problem, because the population in the floodplains and the coastal areas increased tremendously across those areas between 1993 and 2008. So that 1993 flood didn't scare people away from going and building a home that may potentially been impacted by flooding event. So we are partially to blame for some of those societal impacts as well. One of the hardest hit areas around here, you may remember this, was Lake Delton area. The levee breaking in that area and causing a lot of flooding. You had some houses, as you can see, fall into the lake as well. So that's some of the impacts that we've seen. Now, since this event, there have been some changes made, again, because of the 2008 flooding event. Ordinances have been changed. They've changed flooding zones. They have changed coastal zones as well. So there are some actions that have taken place since 2008 to kind of combat. Just like we did after the 1993 flood, we came up with some new policies, new ways to view things, better ways to prepare ourselves to limit the amount of flooding that we experience. Has it helped? Yes and no. Because just a couple years ago, 2018, we had one of these extreme rainfall events move through Madison area. And while they were somewhat impacted by the 2008 event, you still had some very localized flooding. This was the intersection of Mineral Point Road and Gammon Road, if you're familiar with that area in Madison. And some, again, flooding that occurs. But again, over that time, in that 10 years since 2008, we've, again, seen an increase in the amount of precipitation we're receiving at one time. City storm drains can only handle so much water at a time. So how are we going to prepare for the future to handle this? So then let's move to the 2011 Groundhog Day blizzard that occurred. So the frozen type of precipitation, sometimes it's fun, at least for when we're all small, little kids. My kids still like playing in it, but as we get older, we may not want to deal with it as much. So the 2011 event actually started back in New Mexico, impacted the Great Plains up into the Great Lakes region, on up into the northeast part of the United States and southeastern part of Canada. So we got impacted by this storm, but in the path of this storm were well over 100 million people, estimated. This is a satellite view. This is Lake Michigan up here in the very top. To give you a frame of reference, here's the Mississippi River right in here. So you can, and this is all snowfall. This was taken a few days after the event on a clear day, so all the white you're seeing is the snowfall on the ground. So very impactful event. The blizzard conditions were started in Oklahoma and extended all the way up into our area. And we were actually pretty close to the hardest hit area. Antioch, Illinois was the highest recorded snowfall total from this event, and that was 27 inches of snow in this one event. With those blizzard conditions, we get a lot of winds. So one of the problems we faced around here was a lot of drifting. So this is a picture from Pleasant Prairie, Wisconsin. And you can see the snow drifted over the car here and covering the car. This also snarled a lot of transportation methods that we have. Airlines and airports were shut down. The delays in the air travel out of like O'Hare were pretty significant. That impacts the entire country. And then you had places like Lakeshore Drive in Chicago that was completely shut down because the heart of this storm hit right around rush hour traffic. So people didn't heed the warnings that it was going to get bad. They stayed at work, then they tried to leave, and then they got stuck. So again, we're partially to blame for some of this. We've got to take those actions. We've got to understand that those forecasts are there to help us prepare, help us eliminate our risk that's potential during these types of events. So some of the lessons we learned from this, some things that have changed since then. The National Weather Service, who is responsible for issuing our warnings and advisories and everything, they have changed the way they do that. They have been more direct on giving people advice on what to do because of events like the Groundhog Day blizzard that we experience here. From, being more precise trying to be more precise about the timing of the event, how it's going to impact things like travel and people driving. Again, has it helped? Yes and no. Almost 4 years to the day, 2015, so the first one was 2011. Early part of February 2015, we had another pretty significant snowstorm move through the area. Here in Chicago area, they had 18 to 24 inches of snow, so almost kind of the same area got impacted by this. Did we learn our lesson? I think so in this. Because there weren't as many traffic delays. There were some delays at the airports and stuff like that, but that's, again, as they're clearing the snow, but they were better able to handle those delays from the things we learned from 2011. But then we go to 2 weekends ago, and we have an event that's not even close to being anywhere near the 2-3 feet of snow that we saw in the 2011 and 2015 event. We had this small pocket of above 6 inches of snow here through Rock and Walworth and Jefferson County there, and extending over towards the Milwaukee area, 9 inches up around the Dells area. So not as much snow. But it caused a lot of problems because that Sunday, people were out doing their weekend thing, driving down the interstate, and there were major traffic accidents, major pileups of traffic along the interstate. So again, we've changed our messaging. National Weather Service has changed their messaging and given people more information about how to better prepare, better handle these events. But the people have to take those warnings to heart and listen to them as well. So we are partially to blame for this. All right, since it's snowy out, let's talk some warm weather. The tropics. Let's go down into the tropics. We're going to focus here in the Atlantic, the storms that impact us here in the United States. There are hurricanes and tropical storms that occur all over the world. They're given other names, typhoons. Down around Australia, they're called cyclones or willy-willies. But here in the Atlantic, the hurricanes that we experience, we're going to talk about 2 particular events, Katrina from 2005 and Hurricane Sandy from 2012. 2 hurricanes that made quite a bit of news when they were occurring for various reasons, and we're going to kind of compare these 2 as a lot of the researchers have. So overall, from the sense of how are hurricanes changing because of climate change, well, hurricanes kind of feed themselves off of warm air, warm water. So as we've seen these increases in temperatures, we've seen an increase in ocean temperatures to go along with that. And so that should lead us to seeing more hurricane activity. And we have. If you compare the last 20 years of the 20th century to the first 20 years of this century, we've seen a 25% increase in the number of tropical systems that have been monitored by the National Hurricane Center. We've seen a 25% increase in Hurricanes, those storms that reach hurricane strength as well. We've seen over a 50% increase in hurricanes that reach major hurricane strength. That's hurricanes are rated on category 1 through 5 scale. A major hurricane is anything 3 or above. So we've seen over a 50% increase in those events. That's the Atlantic as a whole. United States is just a small portion. So while those numbers have been increasing, the impacts, we've only seen an increase of about 10% of landfalls of hurricanes in the United States. So we haven't felt the brunt of all of those storms here in the United States. But other parts of the Caribbean and the Atlantic have felt some of those impacts. So 2005, the year that Katrina hit, this was a record-breaking year all around. There were a large number of storms, 28 storms that were named that year. So for a storm to be named, it has to reach tropical storm strength, and we had 28 of them. We use an alphabet, A through Z. We ran out. The forecasters that year were like, what are we going to do? This has never happened. So what they did is they started using the Greek alphabet after that. Hurricane seasons, usually June 1st through November 30th. This season extended into January of 2016. We had so much activity that continued on through the month of December and into the early part of January. Other records that were set, we had 15 hurricanes that year, 12 of which made landfall in the United States, Cuba, and or Mexico, all records. We had 4 Category 5, which is the strongest rating a hurricane can receive. Again, another record for one season. So Katrina that year. Katrina started out here in the southeastern part of the Bahamas. It slowly drifted to the north and strengthened into tropical storm strength, the darker blue dots there. Right before it made landfall over the southern tip of Florida, it did strengthen to a Category 1 hurricane. And then it weakened out a little bit as it crossed the southern tip of Florida, which most hurricanes do lose a little bit of their punch when they do move over land. But then it moved out into the Gulf. And the Gulf of Mexico that time was extremely warm. What you're looking at here, the colors in the background, these are sea height anomalies. So as water warms up, it expands. And so instead of getting temperature readings, we can actually measure the height of the water from satellites that we have up in space. And so we have this large area of extremely high sea heights right in the middle of the Gulf of Mexico when Katrina moved off the southern tip of Florida. And again, that's indicative of warm water there, and hurricanes feed off of that. So as Katrina approached that warm pool of water, you can see that it intensified into a Category 5 storm. It was one of the 4 that reached that strength that year. Fortunately for the Gulf Coast states, it did move into a little bit cooler water and weakened a little bit as it made landfall. So some things that we learned, again, similar to what we saw with precipitation, the wording of advisories and warnings we were in this state of flux in the early part of the 2000s from the National Weather Service, National Hurricane Center, the Storm Prediction Center. This text was unprecedented. We had never seen forecasters come out and say something like this within an event. Hurricane Katrina, most powerful hurricane with unprecedented strength, rivaling the intensity of Hurricane Camille of 1969. Camille was only one of 2 Category 5 storms to make landfall in the United States in recorded history. It says most of the area will be uninhabitable for weeks, perhaps longer. Again, this was new. When this was issued by the National Hurricane Center, forecasters were like, I can't believe they're being that strong in their language. But they had to get the point across that this was going to be a major, powerful storm that was going to impact the Gulf Coast states. The other thing that we learned was we were getting a lot better at forecasting these events. So this map that you're looking at is the forecasted track from Friday evening for Katrina. Katrina made landfall Monday morning, late part of the morning, along the Gulf Coast. And this was the forecasted track. The black line was where the National Hurricane Center thought was the best track. Katrina was just slightly to the west, kind of made landfall just to the west of that. So our forecasts were getting better, and that's a good thing. Gives us a chance to warn people further in advance. Katrina was a relatively small, compact storm, unlike Sandy, which we'll see here in just a second. But some of the areas that were impacted, you had some pretty strong winds, 120 mile per hour sustained winds, moving over here in Mississippi, some stronger winds over Lake Pontchartrain there north of New Orleans as well. Here's Katrina. She was making landfall along the Gulf Coast states. In Louisiana, you can see the eye there near the end, and the tremendous amount of rain that it was producing. So there's the eye of the storm. That's the center that we track that path of. Again, in a relative sense, this was a pretty small hurricane. This could have been a lot worse. That warm pool of water could have been a little bit further north, and we could have seen Katrina come in landfall at a Category 5, which would have been even more devastating for the Gulf Coast states. And we already saw things like this once the storm cleared out. The damage from wind and storm surge along the Mississippi, Alabama, and Florida Panhandle coast was devastating. The events in New Orleans, the breakage of the levees that caused Lake Pontchartrain to fill areas of New Orleans was devastating. Probably what we maybe remember the most from this event is what happened around the Louisiana Superdome during the event and after, at least from a meteorological standpoint, some of the stuff that happened during the events, but then the aftermath, that's what kind of made the news. People that didn't heed the evacuation warnings for New Orleans or didn't have the means to evacuate flooded into the Louisiana Superdome for refuge. And you can see the damage that was caused there in the picture to the right. The roof was peeling off. They thought at times that the roof was going to come off with thousands of people inside. We did lose over 1,800 people during this event. There was more than 1,800 fatalities from this event. It could have been a lot worse. And you can see, again, in the background of this picture, you can see some of the flooding. This is all water in the streets and surrounding those buildings. The aftermath that ensued after that, we'll come back to in just a second. But let's take a look at 2012, the year that Sandy happened. So again, it was a very active season, 19 named storms, not quite the 28 that we had in 2005, but still a lot of storms, increased activity in the Atlantic. Sandy ended up being the strongest hurricane of the season, and it only reached Category 3 strength. So Sandy started south of Jamaica, took that northerly track, made landfall in Jamaica as a Category 1. When it got into this area between Jamaica and Cuba, there was a pocket of warm water, and so it intensified. Luckily, it didn't have a lot of time there, so it only got to Category 3 strength when it hit Cuba, and then it started moving out towards the Bahamas and towards the East Coast. And again, this shows some changes that we saw with this event. About 10 days out, when this thing was crossing Cuba, some of our forecast models were starting to show that Sandy was going to make this hook to the northwest. That is unprecedented. We've only had less than a handful of storms that have ever done that in recorded history. We've had a lot go straight north and hit up in the New England area, but nothing that's ever started to go out to the Atlantic and cut back to the northwest like this. Very few storms. And at first we were like, that can't be real. The forecasters were like, and the model that was doing this was the European model, and they were like, it can't be real. That's not reality. Storms just don't do that. Well, Sandy ended up doing that. And so the forecast came true. Other models started to pick up on that 9, 8 days out. So again, our forecasting is getting a lot better. As Sandy started moving up the east coast of the United States, it became a very large storm, record-breaking in terms of the size of the storm. It wasn't that powerful, wasn't at the Category 5, but it was large. The tropical storm strength winds, this tropical storm, to reach that status, you need 39 mile per hour winds. That was over 1,000 miles wide. This was a large storm, the largest on record for us. Now there's some debate. What was Sandy? Well, it was a hurricane when it hit Jamaica and Cuba. But as it's moving up the East Coast and ended up making landfall along the East Coast, what was it? Was it a hurricane? Some people want to call it a superstorm. And the reason for this is because this thing was so immense, it started to draw cold air in from Canada. It was that large and having that large of an impact. Once tropical storms start ingesting cold air, they tend to die off. Sandy didn't. She kept going. She kept getting stronger. The winds increased a little bit. Fortunately, as it made that western hook, it started to weaken, and on October 29th, it made landfall in New Jersey. And again, did a lot of damage. It was the highest sustained winds that were recorded when it made landfall, 80 miles per hour. So still hurricane strength, still had a somewhat of an eye like we see with the hurricanes. So again, what was it? Was it still a hurricane? Was it not, because it ingested that cold air? But again, it was a large storm. Clear out in central Pennsylvania, large trees coming down because of the intense winds as Sandy was making landfall. In Manhattan, just to the north of where it made landfall, lots of power outages, lots of flooding. This is the Battery Tunnel in New York City that got flooded, and there were videos and pictures all throughout the area of flooding in the subway system throughout New York City. That cold air it ingested, mixed with all the moisture that it had picked up, created a pretty significant snowfall event for those living in western North Carolina, western Virginia, and West Virginia. Some areas received up to 3 feet of snow from the event. It also impacted us here in the Midwest. Again, that wind field was extremely large. We had large, strong winds over Lake Michigan, and this is some video from the Chicago area when those strong winds were moving over or impacting Lake Michigan and impacting Chicago there. So let's compare these two, Katrina and Sandy. And there's been a lot of debate going on about these two storms, mainly about the response of these storms. On one hand, you have Katrina. It was in the middle of President Bush's, one of his terms. Some people question how he responded to getting aid to New Orleans. Sandy, 2012, a month and a half, well, just over a month from the 2012 presidential election. The response by President Obama was totally different than what was down in New Orleans. There's people that question the motives behind that and whether there was some environmental injustice going on. New Orleans being a poor city, a poor community, and our response that we gave to them versus New York City, which is a little wealthier than New Orleans. New York City, media capital of the world, New Orleans not. There's a lot of debate going on by social scientists and physical scientists about the difference between these events and the response that we had them. But what about climate change? Again, we have seen an increase in storms. Kevin Trenberth, who's a senior climatologist with the National Oceanic Atmospheric Administration, or NOAA for short, if you've heard it by that name, says the answer to the oft-asked question on whether an event is caused by climate change is that it is the wrong question. All weather events are affected by climate change because the environment in which they occur is warmer and moister than it used to be. And he said this was something that he was quoted of saying after Sandy, and asking if this event was caused by climate change. And I think that's telling. Again, we're getting warmer. We're getting more moisture in the air, so we would expect to see an increase in these types of storms like hurricanes. Finally, let's talk about thunderstorms. This is probably the area that I'm most interested in. As was said when I was introduced, I have been chasing storms for going on almost 20 years now. So I've studied a lot about tornadoes, tornado occurrences, and the history of tornadoes from climatology standpoint, but also kind of weather-wise and why things occur. And what I want to focus on is the 2011 tornado season, again, to kind of show societal impacts here. Again, comparing the last 20 years of the 20th century with the first 20 years of this century, we have seen an increase in thunderstorm activity. But there's a lot of question about that. It's not as strong of a connection as we see with precipitation or with hurricanes. And that's because we really haven't been keeping track of tornadoes and other thunderstorm activity for that long. And our methods of reporting things have changed tremendously from the 80s and 90s to today. And so there's some question whether this is a changes because of climate change and we are seeing an increase, or is this a change because of the methods in which we report? So there is some question about that. So I'm going to focus more on the societal impacts. First day we're going to start with is April 27th, 2011. This was a day, that one day of a 4-day tornado outbreak across the Great Plains and southeast part of the United States. The map that you're looking at here, these are all the warnings that were issued just on the 27th from that event. Red boxes, tornado warnings. Yellow boxes are the severe thunderstorm warnings. Green boxes are the flood warnings that were issued. Over that 4-day period, we had 360 tornadoes occur. 22 of those were rated EF3. That's about halfway up the scale. 11 of those EF4, and 4 of those were rated EF5, the strongest rating a tornado can receive. Again, some of these were close to, they tied records or broke some records with some of those numbers. During that 4-day event, we had 324 tornado fatalities and an additional 24 weather-related fatalities. On the 27th alone, this day right here, 317 tornado fatalities. That was the most one-day tornado fatality count since 1925. We went almost 100 years. We had to go almost 100 years back in the records to find something that big. So here's some video of one of the first storms of the day. This is from Reed Timmer, who's a fairly well-known chaser. If you watched Storm Chaser show on Discovery Channel before, he's one of the people they focus on. This was in Mississippi, near Philadelphia, Mississippi, pretty rural area. But you can see, again, the intense winds here. You can see the debris flying around. The problem with this event on the 27th is we went from rural areas to urban areas. This is a tornado that is occurring in Tuscaloosa, Alabama, which was one of the hardest hit communities on the 27th. This is news footage from one of the sky cams from the ABC affiliate out of Birmingham, Alabama, and there is a tornado on the ground. It's hard to see because of all the rain that's wrapped around it. And you'll see it a little bit better here in just a second. One of the technical problems we're having is audio. I was hoping you would be able to hear the TV meteorologist talk about this because he's giving people some good advice. And there you can see the tornado a little bit better. We can get closer to this event because there's a lot of video out there. Here's just one of them. This is from the ground, from a person that was out shopping and recorded this storm. Again, a very powerful storm. This one was one of our EF5 rated tornadoes here, and this is moving through a very populated area of Tuscaloosa, Alabama. Again, you can see some of the debris flying around. The camera is shaking because they are getting hit by winds that are so strong, even though they're probably a little bit too close than I would, even as a storm chaser. Because again, that wind they're facing is pretty strong, could easily pick up some stuff and cause debris to fly around even where they are located. So again, a very powerful event, and that's just a small sample of the videos that are out there from the 27th. Less than a month later, May 22nd, 2011, we had another tornado move through another very populated area, and that was in Joplin, Missouri. This was one lone tornado. It ended up being rated an EF5, the strongest that we can have. And this lone tornado caused 166 fatalities. That was the most from one lone individual tornado that we had seen since 1947. This also set a record. It caused more than $2.8 billion in insured losses in the town of Joplin. Here's some video from this one. This is from a pretty well-known chaser, somebody that I respect. I've seen talk at many conferences. I've met a few times out in the field. Jeff Petrosky and his wife, Catherine, and some of the video they shot of Joplin. The big flash you just saw was a power line flash. It was not lightning, transformer blowing as it hits power lines and substations. And again, here's some of the damage that they drove into, again, minutes after the storm went through Joplin. Pretty devastating event. Again, 166 people lost their life on this day because of this event. Just some more damage here from the aerial shot. Now, I bring up these two events because, again, I've studied tornadoes, been fascinated by tornadoes since I was a kid. I never thought I would see a tornado cause that many fatalities. I never thought I'd see an outbreak that caused that many fatalities. I had confidence in the National Weather Service for issuing warnings. But again, it goes back to humans and how they react to them. So as an example, let's look at the Joplin timeline here. So at 1:30 p.m. Central Time, a tornado watch was issued. Watches, conditions are favorable. Issued even before anything even starts, even before the thunderstorm starts, they'll issue watches. This was up until, I think, like 10, 11 o'clock at night, so watches are usually for a long time period. At 5:09, the first tornado warning came out. Warning, tornadoes on the ground and has been spotted, or we have indication on radar that there's a thunderstorm that could produce a tornado. So there is that distinguishing factor now with our tornado warnings. So the first warning for the western side of Joplin was issued at 5:09. 2 minutes later, the siren sound in Joplin to warn people that the tornado warning had been issued. 6 minutes after that, 5:17, a second tornado warning comes out. Basically just an extension of the first one, including the entire city of Joplin, Missouri. 17 minutes later, from that second warning, is when the tornado touched down. 17 minutes of lead time for people to take shelter. That's above normal. Usually the average is about 12 minutes of lead time that forecasters give. About 4 minutes later is when the tornado finally crossed into the city limits of Joplin. So between the time of that second warning, which included all of Joplin, that 5:17, we had 21 minutes before the tornado even crossed into the town of Joplin. But we still lost 166 people in the town of Joplin that day. Warnings were continued on as the storm moved through town and started moving out east. So after these two events, the April 27th event with high fatality counts, the high fatality counts in Joplin, researchers were like, what is going on? Why did we see this? We were all asking, and the whole weather community asking why this happened. And we found out some interesting things. What they did is went in and started interviewing survivors. How did you react? What did you do? One finding that they found is that more people relied on the sirens than any other method to get their warning. They didn't have a weather radio. They didn't listen to the news on TV or radio. They relied on the sirens. Problem with sirens from the weather community standpoint, it doesn't tell you the risk. It just tells you something's going on. And some communities issue it even if there's just a severe thunderstorm that could produce some hail and some straight line winds, let alone a tornado. So you can't judge the risk and the level of risk. Second interesting finding, people didn't believe the first warning they got. If they heard the siren, and it didn't matter what the source was, whether they heard it on TV first, radio, heard the sirens, they didn't believe it. On average, the people that were interviewed from the two events had to get it from 4 sources before they would believe it. That takes time, right? That first warning comes out at 5:17. Okay, I got to go check. I don't believe them. Oh, they're saying it on the news. I still don't believe them. That's all taking time. That's eating away at that time that you can take cover. From that, what we kind of concluded was, and when I say we, the weather community, is that warnings had lost their impact, lost their credibility. It's kind of the cry wolf syndrome. And a lot of people mention this. Well, the sirens go off all the time and nothing ever happens. So that was the same thing that was happening this day. I mean, there's personal stories that some researchers shared. You know, there was a guy in Joplin, heard the sirens, turned on the TV news, heard the warning, went outside, smoked a cigar on his front porch until he started getting pelted by debris and barely got to shelter because the tornado was coming from behind. There's people in Birmingham and Tuscaloosa area, heard the sirens, heard the warning, called their friends. Did you hear the same thing? Check social media. Is it on there? And then turn on the TV news and see news footage like that. Still don't believe it until they look out their window and the tornado's right there. Again, not enough time to take cover at that point. There's lots of stories that were shared like that. I am a geographer, so the next one hurts me. People don't know where they are on a map. They couldn't locate themselves. If you asked them, were you in this warning, and show them a map, I don't know where I live. That, again, maybe that's just a generational thing for us. They didn't know where they lived. And so people like James Spann, again, I wish you would have heard the audio. He's really good at his job. He's won multiple awards. One thing he's really good at is he knows his area. Hey, this tornado, then there's footage out there. If you want to watch tornado videos, there's lots of them. Just search James Spann, April 27th, you'll find. And he'll be like, the tornado's moving through this intersection. That's where the Walmart, Target, Publix, Plaza is. It's going to be moving here, which is where this donut shop is. I mean, he's using landmarks, and that's what people found to be effective when he used those landmarks for them. The other thing for the younger generation is they want their warnings differently. They want it through social media. And so some things that have changed since these events, the National Weather Service has gotten a lot better using social media. They're almost every office that I follow on social media, they post their warnings and watches and advisories and all of their products on Facebook and Twitter and all of these social media platforms, because the younger generation, they don't turn on the TV, they don't watch the news. They're streaming Netflix, so they don't get the warning through that method. They don't listen to the radio. They're streaming music through Spotify and all these other streaming services. So we got to get a way to connect with those people, and that's a way that we can do that, because they said, the younger generation that were interviewed, the survivors said, we didn't know there was a warning because we don't do those things. We don't watch the news. We don't listen to the sirens. We didn't grow up in that era. We don't know what that means. And so that we have to think of new ways to reach those communities. So again, over the last 20 years, we've had some increases in storm activity because of climate change, but these things are also impacting us, and we're, humans in general, are to blame for a little bit of that. We got to listen to those warnings, those advisories that are issued, and take the advice that the National Weather Service is giving us. You know, that's what their job is. Their mission is to protect life and property. It's one of the first lines of their mission, and so that's what they're here for. They're here to protect us, so we just need to listen to those warnings and understand that things are changing due to climate change. So where are we going to go in the future, and how are things going to change over the next 20 years? So thank you very much for having me and attending the presentation.
We have time for a few questions. Sure. Let me make my way over here.
I'm going to get a drink of water while you're doing that first one.
Is there a lot of difference between the models of the European meteorologists and the American ones? And do they have these types of activities, meteorological activities, in Europe as well?
So Europe gets, they get storms. They don't get hurricanes like we do. They're too far to the north, so they tend not to get, but they get a lot of windstorms. This time of year, they get low pressure systems that move through that produce a lot of rain and windstorms, and not of the tropical nature. There are tornadoes that occur there. So that kind of answers that second question that you had. They do experience this. As far as the models, yes, there's weather agencies all across the world. You know, Canada runs their own weather service. Europe, the European Union runs their. The United Kingdom has a separate meteorology office. Japan, China, India, Brazil. So all of these countries run their own weather service. They go by all different names, but they're essentially like our National Weather Service. And all of these have their own models that they use. Fortunately for us, though, a lot of these models are open record. I don't know what the correct term is. It's open record. Anybody can get access to it, because in most countries, and just like here in the U.S., it's funded by taxes. And so part of that is that the data has to be available for free. So I can go in and look at the European model for free. I can look at models from Japan and Brazil. Back in the early 2000s, you know, I brought that up about in kind of early 2010s, there's a lot of competition, especially between the Europeans and the Americans, on who had the better model. And unfortunately, they did a big upgrade in the early part of 2012. And that was, I didn't mention that, but that was part of the reason why people are like, that's not true. Sandy's not going to curve to the northwest like it was first predicting, because they had just upgraded their model. We hadn't gone through a hurricane season, so we didn't know what the new upgrades were going to handle, how it was going to handle that. So that was why there was a little bit of question there. Now, and this competition has continued. Like, they'll do an update and improve something. The U.S. scientists will come out, we're going to up our model this, and then they do something. And it's good, right? That's healthy competition, because that helps us forecast for these types of events. So, yes, there's models everywhere. Yes, it brings on some good competition that I think we need to get better at forecasting. And we've continued to get better. I mean, forecasts are getting better and better every year because some of these upgrades that are occurring.
Okay, let me bring the microphone here.
You made the comment that with Sandy, it was unprecedented that it turned. So I guess two parts to this then is, how do they track that without getting too, involved with low pressures, high pressures and all that, but what forces the movement directionally, and what technology is there to track it?
Sure. Let's go back to that slide because it may be easier to. Give you a little weather lesson here. Just a small one. No exam. I'll save that for my students down the street. Okay. So with Sandy, again, most hurricanes, if they take this path and they start to make this turn to the northeast, they continue on that way, okay? What happened with Sandy, and looking back on it, was like, okay, yeah, no kidding, the model was right. Like, we should have seen that coming. Sitting out here between the eastern coast of Canada and Iceland, there was, that time, a very large, one of the highest recorded pressures in the northern Atlantic that we'd ever seen. The basic thing you need to know about high pressure, well, it brings us our good weather, so we kind of like those sometimes, right? Highs circulate clockwise. So the pattern with that high is moving this way. That high was so dominant that it blocked Sandy from going up there, and that's what turned it in towards the coast. It was usually, though, there's highs like that sitting, there's highs sitting up there. A lot of times we have hurricanes move up the East Coast, but we've never had one that strong sitting in place as a hurricane move that way. So usually the hurricane's powerful enough, it'll kind of push the high out of the way because it's the stronger storm. This case, the high was the stronger object in the atmosphere at the time, and so it kicked Sandy over towards the East Coast of the United States. So that's probably as basic as I can get an answer. There was a second part?
I'm just curious, what forces the hurricane to move?
Yeah, so...
And it will track for warmer water and those type of things, but in general, you don't see just a slight variation in water temperature there, so what was it?
Yeah, I mean, the big thing, again, as it makes that kind of northerly turn, that turn to the north, it's all about where the high is sitting. The hurricane is the low, so that's the low pressure. In the summertime, late fall, that high is usually sitting, we call it the Bermuda high, and it's usually sitting down here, kind of central part of the Atlantic. But that year, it had shifted up north and it got extremely strong. And so that is what was influencing the path of Sandy. Now, the reason, not Sandy, not necessarily Katrina, but a lot of our storms start out here in the Atlantic. They move this way because that's what the wind patterns are doing down here in the tropics. So the winds push it this way. It finally reaches where it starts to move to the north, and then it's going to be dictated on where that high is sitting. Is it way down south? Then the storm's going to stay south, hook around the outside of that. If it's up here, starts to move up, gets blocked, gets pushed that way. So it kind of two little factors there that are important in where that storm tracks.
So with that, we'll do one more quick question, but then that's all we have time for, I'm sorry to say.
Have you ever been caught in a storm when you're storm traveling?
Close enough. We'll just say that. I've been within about 200 yards of a tornado before. Not by choice. It kind of snuck up on us. We weren't expecting it. It was a squall line tornado, which is, squall lines are the type of storms we typically get around here. They're a lot harder to predict where the tornadoes are going to occur. The ones that happen out in Oklahoma, Kansas, those are from supercell thunderstorms. Those are easier to track, and that's why we usually go chasing out there. But this one, we were watching a squall line came in, and it literally started like 200 yards in front of us. But when I do this, we're always safe. You always stop at somewhere where you have at least 4 directions of escape. And when it happened, we're all sitting in the car because it's raining a little bit. We don't want to get wet and be miserable the rest of the day. So we're sitting in the car, and we just took off the other direction real quick, and we turned around, and we got some pretty cool pictures and some video of it but it was a little dicey there for a couple seconds, but we're all good.
That's great. We'll leave it there, but if you'd like to talk to Dr. Frye, please go ahead. Thank you all for
Thank
coming
you.
today. Thank you.